The follow-up is, what if you cannot modify the input list? What they are trying to say is reversing the list is not allowed, right? Hey everyone, this is me Rachit and welcome to yet another video. So today is the day 3 of the coding interview preparation series, and in the previous 2 videos we have covered dynamic programming in a lot more detail. Like I think we have around 1 hour of video content for that. We have solved around 4-6 problems, having covered dynamic programming in a great depth. Now I want to shift the focus on day 3 to linked list, and this is one of the most underrated topics, guys, because if you're really good with programming, you feel that linked list is so easy and you generally skip this and move on to binary search trees and graphs. Okay, so that's one of the, I would say, wrong things that you are doing, because in interviews linked list is very hot topic and the questions can be really easy to solve, but the interviewer generally puts some other constraint on the interview question to make it more difficult. Like they will say, okay, you did it, like that's easy, but now try to do it without using extra space, or try to do it in this much time complexity. So they, or try to do it in one pass of linked list. So they make this question really tough, and if you are not already experienced such problems before on linked list, I think you will make much more blunders and your interview chance like will really drop down. Just to highlight this power of linked list questions, I actually have made one video in the previous videos that I have, which is titled how linked list will screw your interview. So make sure to watch that, and I'm sure if you stick to the end of that video, you'll come to know how linked list can actually screw your coding interview. Also, if you want to go into deep dive into pointers and how linked lists work, how they interact with memory, so I would suggest you to go into that. I have covered the implementation details of linked list in a lot of detail. So in this video, I will be basically solving question from lead code and then writing the solution in C++. If that does not make sense to you, make sure to check this out. Again, guys, thanks for sticking around, and now let's solve maybe 2 or 3 problems on linked list. So we are given 2 non-empty linked lists which are representing 2 non-negative integers. So it means it can be 0 as well. Okay, and they do not contain any leading 0. Okay, and then follow up is, so what do we have to do is basically add to linked list. So if this is one linked list and this is other, we have to add them and return a new linked list, right? So guys, it really looks easy to solve, right? You are given 2 linked lists, they can be of different lengths, and addition starts from the units place, right? So what you can do is basically reverse the linked list, and then you can basically have you can point at the, so once you reverse the linked list, the head of both of them is pointing to the ones place, and then when we do heads next, we go to the tens place, then hundreds, then thousands, and so on. So in this fashion, if we reverse the linked list and do the summation and create a new linked list, it will be easy for us, and then we will reverse the new linked list that we have created, and then we will simply return the pointer to the head node. So in this way we can solve this, but as you can see, the follow-up is, what if you cannot modify the input list? What they are trying to say is reversing the list is not allowed, right? So if you say that reversing the list is not allowed, it really becomes a bit tricky, or maybe you will take some time. So let's see what's going on. So, and I will zoom into this. Okay, so what I mean to say is, let's say your first linked list is 7, 2, 4, 5 and 8, and the other one is 5, 9, 5, 8 and 8, right? So the final linked list should look something like this, right? And how do we do this? We started from the ones place, which is this, right? And then we basically did the carry forward and move in that way. So now reversing the linked list is not allowed, and we have to basically return something like this. How do we do this now? So what we need to have is basically we need to traverse both of the linked list and reach to their final last node, which is the ones place, right? So in this example, so let me just change this value to make this a bit clear. So in the first linked list, 8 is at ones place, and in the second linked list, this 3 in the last place, ones place. So what we need to do is we need to process these 2 linked lists so that we reach to the last node in both of them. We do the addition of them, create a new node which is 6, and we keep on storing the carry forward that we need to take here. Now we don't have the previous pointer, so we need that in some way or the other. We need them for both of the linked list. So I think it's quite clear for me, since we have to do some repetitive operations on both of the linked list. I will basically wrap them up in some common class of structure and use that to make my code a bit cleaner, right? So now, did you realize what just happened? You could have done this in like bare, like copying and pasting the same code for the two linked lists. So the main crux was to get the previous node pointer, right? And we are not storing that. We just have access to the next pointer. So to get the previous pointer, it's not a difficult problem, but it's a problem that we are encountering for both linked lists. So did you think in this direction that you should wrap them up with the common class, which is having the linked list inside it and exposing this functionality to also get the previous pointer? If yes, then basically this is a good point that the interviewer will be writing down. And that's the beauty of interviews. Like when you're giving interviews, you are really just focusing on solving the problem, but the interviewer is also doing his or her job. Once the interview ends, they will have to write the feedback. And if you write code in a better structured way, it will reflect good, right? Because what happens in interviews is, and I'm saying this because I have taken interviews, is that once, like, let's say there were 100 candidates and then 10 candidates were narrowed down, then out of those 10, you will finally be inviting them to onsite, and then you will see that 5 of them can actually do your job. Now what you are interested in is the behavior of that person, like does he or she fit well in the culture, and do they bring something new to the table? Because technical skills, you feel that all 5 are like compatible enough, they can do the job. So then what matters most is how the candidate thinks. And if you demonstrate all such things like I have just mentioned in interviews, it will really reflect quite well. Okay. So even in simple questions like linked list, you can demonstrate a lot of things which a good software engineer should have. So let's quickly write the code for this one. Okay. I would basically zoom back, create one file. What is this lead code problem? It's 445. 445.cpp. All right. Okay. So how do we have to solve this? In C++. So this is the function that that lead code is expecting us to implement. Add two numbers, and we have the headers of both the linked list, right? Okay. So what do we need to do? First, I think I can include the basic stuff so that I don't get error from Visual Studio Code. Okay, so now, and again guys, I'm not editing these videos, just to show you how much time it generally takes for software developers to solve problems and write code. So I'm taking things like really easy, if it's like, because I'm also explaining things side by side. But in real interviews, I generally tend to first discuss the approach that I have real fast with the interviewer, and once I get a green signal, I simply start ahead with the implementation. And when I'm doing the implementation, I make sure that I'm not basically first implementing that wrapper class that we have discussed. I first believe that we already have all those things set up, and I simply write the code. And once, because this actually saves time, and once we are writing code, I will actually deep dive into that and explain what I'm trying to say. It might not make sense right now. Okay. So we can't reverse the linked list. So two linked list, add them. So I need, yeah, so I need to wrap them up. Okay, so let's say I wrap them up with some class. Maybe I will use some class, maybe node, maybe node. So naming, I really take a lot of time. For right now, I'm using a struct node. What it does is it takes in list node, sorry, list node head, and it does something. I'm not interested in that, but one interesting thing that it exposes is something like list node star get previous and list node star current, and in some way or the other it will get me the previous node. So now using that, I will be implementing my solution. So what I'm doing over here is node A, and I'm passing L1, then B, I'm passing L2, right? That's the first thing that I have done. Then what I have done is this thing will also give me one more thing, list node star get tail, and it will simply get me the tail of the node it is storing, right, which is passed in the constructor. So now what I can do is basically list node star first one. So we can do a dot get tail. So get tail. Uh, shall I zoom in a bit, because I think many of you will be watching this from mobile. So yeah, a dot get tail, and then we can simply do something like second for the second one, b dot get tail. So now we are at the tail nodes, and let's say the carryover is initially 0. Now what we can do is basically while f is not equal to null and s is not equal to null. So what is the structure of this node? Let me just look at lead code. So okay, so it's having an int val. All right. So int current sum is basically fval plus sval, oops, plus carry, right? That's the current sum, and let's call this sum actually. And now we have to create a new node, and for that, what is the syntax? Okay, so they have a parameterized constructor which will do that work. So of course we have to return the node back, like the result is null initially, and after doing something we finally have to return that. All right, oops, I think we have used result. All right, so what can we do now? So what we can say is if result is null, results equal to, I think, new linked list, new list node, and we can simply pass the val. So now right now if you pass this sum, it will be wrong, because if the units place digits were 7 and 8, the total is 15, but what we want is just the 5. So you need to do modulo 10 over here, right? That's fine. And if result is not null, what we can do is also so basically result is something which we will return at the end, and we also need to keep on appending the new nodes that we're creating, right? So that's something which you also need to take care of. And again, just keep in mind that we are iterating from the reverse direction. So this node that we are creating, the next node should come to its left hand side, and then the next node should come to its left hand side, and so on, right? Make sense? So basically what I'm saying is first we create 6, the 4 should come to the left side of 6, then 8, and then 7. So that's what I meant. So that's what I meant. So if result was null, we basically initialized it. Otherwise, what we can do is we need a new node, and for that we can say list node star pointer is equal to new list node sum modulo 10, and then what we can do is pointers next is result, and then result is pointer. So what I'm doing is inserting the current node to the left hand side. So basically, finally, if we keep on doing this, we can simply return result, because that will be the head of the new linked list that we have to return, right? So 6 was created, then in the next iteration we created 4, and we make sure that 4 next is 6, and then we updated our result to 4, which is the newest thing that we have. Then we created 8, we said that 8's next is 4, and we ensured that now result is pointing to 8, and then we will create 7, 7's next will be 8, and then we will make sure that result is pointing to 7, and then finally when the loop ends we will result the node result. So that will be the head of the node. So that's what I'm doing over here, ensuring the new nodes are added to the left. Okay. All right, this looks good, and we need to make sure that we are updating the carry function. So now carry will be nothing but sum by 10. So if the sum exceeds 10, it will be 1, otherwise it will be 0. So yeah, and then we need to update. So now f is nothing but let me check. Yeah. So now what we can do is f is equal to a dot get previous, and I can pass f, and then I can say second is b dot get previous. So as you can see right now, the naming is so bad that it's actually difficult for you also to understand. So what are A and B are my wrapper nodes that I have created, and I am so A is containing the initial linked list L1, B is having the L2 thing, and F and S are basically just pointers to iterate them in the reverse direction. So I am interacting with the A and B wrappers to update the values of F and S so that I can proceed in the reverse to front direction. Alright, and as soon as something gets null, so in this case, as soon as 5 gets null, we need to make sure that the rest of the linked list, whichever is not yet full, whichever is not yet, so whichever has not exhausted, we need to replicate that. So in this case, basically, when the while loop breaks, we will have something like 846 because 583, the second linked list has exhausted. So now we also need to ensure that one of the linked lists may not be exhausted, and those nodes should come itself, and the carry should be taken care of also. So yeah, guys, I think it's a very good question if you look at it this way, like so many corner cases, and it will be fun. Like, what if we also had an 8 over here? So the new linked list will be having 5 nodes. So are you handling that? So I think it's a perfect, very good question, I would say. All right. So once I'm out, it may be the case that either f is not full or s is not full, and I also have this carry variable. So while I will say f is not equal to null, I need to keep adding, so just give me a second. Right. So now the sum that should be will be carry plus, let's see. Yeah, one of the interesting edge cases that I want to share with you is, what if one of the linked lists is this, and then the other linked list is simply this, right? So when we come out of the while loop, we'll be basically, these many nodes have to be processed, and then as you know, all of them will have the carry over, and then a new node has to be created with 1, and all these will turn into 0. So the current sum is carry plus f val, and then we create a new node taking the modulo. That works, and then we also need to update the carry. So carry will be sum by 10, and also we need to update the f. So a dot get previous. Awesome. Similarly, we will repeat this for s while s is not. So I will use command D to quickly navigate to all f and then make it an s. All right, done. Cool. So if one of the linked lists is not empty, what we are doing is iterating on that, adding the carry, taking the sum, creating a node, creating a new node, and over here, pointers next is result, result is pointer. Awesome, guys. I think this seems to work. The only problem is, now what if there is still carry? And this is the beauty. If there is still carry, of course it will be 1, and what you have to do is just this much part, wherein this will be of course 1 now, and pointer next will be result, and result is pointer. Awesome. Now I think this is perfect solution for this. Let me zoom out to see what we have. All right, I think this was a bit lengthy one. Wow. And it will, of course it won't compile right now because we have not done this wrapper thing, like we have not written the implementations of these functions. So let's also do that and see if we are lucky, right? So see, this question was easy to solve, but once the constraint was added, it really became actually fun also to solve. So now what I will be using is something from C++STL, and I am so happy that I already have the prerequisites covered. So if you will simply search C++STL, I think the first video that turns up is mine, coding interview C++STL in 45 minutes. Just watch this, guys. Trust me, just watch this. The ads. Just watch this. It has really high percentage of likes and dislikes. I think 99%. It covers everything: sets, vectors, pairs, maps, upper bounds, and also how we mix all those things to solve problems in interviews. So now I will be basically not explaining how what does map or unordered map does, I will simply be using that. All right. So this is the head node that we have received, and what I will do is while head is not equal to null, um, I will initially have list node star previous, which is null, and then what I'm going to do is nothing but in my map I will be storing that what name shall I give? I think underscore pre is a good name. Of course, we should take more meaning like previous node, but in coding interviews, I generally makes this point that right now I'm using a short name. Maybe in production code, I will use much more meaningful names. Just to save time, I'm basically using smaller names. So underscore pre. Underscore is basically a general format, like for the private variables or something. Private data members, we generally append prefix them with underscore. And this is struct, so everything is generally is actually public right now. But yeah, I just wanted to make sure that I'm saying all such things when I'm talking with the interviewer, because otherwise if they look at this code they will say that it doesn't make sense. But yeah, I just iterated on that. Okay, so underscore pre is a map which takes the current node head and stores the previous pointer, and now pointer is head, and then head is basically head next. So basically I'm iterating on my linked list in positive direction, and I keep on storing the previous pointer as well. And when I'm at the current header, uh, basically head is I'm using head to iterate through the linked list. And whenever I am at a current node, since I'm having the reference or the pointer to the previous one, I'm storing that in my this map. So let's also define this bad boy over here. Okay, so it's basically an unordered map which is based on hashing to get O1 lookup on average. So unordered map of what? Again, let me zoom in. Otherwise, the phone viewers will be having a bad time. Okay, so unordered map of what? Of list node star to list node star. That's it. Underscore pre. All right. I think this looks good. That's all we have to do. And over here, what we can do is simply return underscore pre of the current node. And for getting the tail, what we can do is I see. So get tail is also something which we are expecting. So let's also store that. List node star underscore tail. And what we can do over here is, as we are iterating, underscore tail is head. So basically when this while loop will end, underscore tail will be pointing to the tail node. And over here we can simply return underscore tail. Awesome guys. So did you see, we just kept in mind that such a node exists which will give us this functionality, and then we proceeded with writing the code. This is useful for you in two ways. It might be the case that when you are writing code using that class, you will realize that, oh, this is not functioning, like this is not solving the purpose. So that is one thing, like you quickly come up with the result that whether this approach will work or not. Second is, let's say your timer is running very less and interview is about to end. They will be much more interested in seeing that you have actually solved the problem, which we have done over here, right? If you just give this node implementation which is doing get priv and get tail, they are really not interested in that. The question was something else and you haven't solved that. So that's why I really prefer that you break down things into smaller parts and expect that these smaller parts are there with us right now, and you will implement them later only if you have time and only when you're sure that the solution will work. Otherwise it will be a waste of time, right? So yeah, I think this should work now. Let's zoom back to see the final length. Okay, not proud of it, but let's see whether this is functioning first or not. Okay, I think it won't compile in the first go, because we know that getting the solution accepted in first time or even compilation at the first time is a myth. All right, let's run code and see where is the error. Oh, it actually worked. So basically, if you are having a lot of problems in making progress with preparation for coding interviews, I think what I recommend to even my relatives and friends is algoexpert.io/Rachit. and it's a great website which is designed by developers from Uber and Google. Basically, once you buy it, they say that you own AlgoExpert. But the important thing which sets this product apart from the others for coding interviews is that they have 70 videos which can cover an entire spectrum from arrays to binary search trees to dynamic programming. You can see so many videos on dynamic programming, again heaps, graphs, and there are new videos which are coming up in this particular course. They have entire portal dedicated for every problem. They also have a video solution at the end, so in case you are a beginner and you are facing so many problems in understanding, so they really make sure that they dig deep dive and also provide you solutions in multiple languages. For example, in this particular question, you can see the problem statement over here, you can write your solution over here, you can also view the video solution, which is around 28 minutes long. So their video solutions are comprehensive and so much detail for beginners. So as a beginner, within a short amount of time, you will really make a good progress. You can also see their solution, and you can also basically select the language that you want to see the solution in. And I think it's really good, and people have been using this portal for a long time now, and as you can see, the reviews are also pretty great. People have been using this to crack jobs in like really huge tech brands. So I would definitely recommend you to go to algoexpert.io/Rachit, and you will get this beautiful message. And don't forget to use Rachit as a coupon for 30% off. So guys, it actually worked, and I am shocked, getting no compilation error in the first time, and also the solution is right. Let's submit this now. I was getting my hopes up. So the interesting thing is we missed this case. So one is 0, the other is 278. We are simply returning 78 while the expected is 278. Why will we do that, guys? Really, so bad. Let me just turn my AC back normal, otherwise it makes a lot of noise. Sorry about that. And also I won't be editing these videos. Damn, I wish I could have edited and removed this. Okay, so why is it happening? Let's try to understand why this is happening. Okay, and I think this is a situation which actually comes in interviews as well. So let's take things step by step. So we wrap things up in our pointers. I think that's fine. And then get tail, that's also fine. So what would have happened is, after the first iteration of so 0 and 8 would have been processed, so we created this 8, and then we would have, so basically f would have became null, right, and s would be pointing to 7, and then we come over here and we are doing a.get previous and while s is not null. So I think this should work. So basically after the first iteration, while so f is null, so this won't get executed at all, s is pointing to 7, so it does 7 plus carry 0, so we create a new node 7, and then we do all those things, and then we do s is a.get. Oh, it should be b. So yeah, there is a problem. All right, I think this was a good one, and I'm sure this will pass now. Let's quickly go over here, paste this, and then run code. Oh, I should have not run code. I'm sure it will work. And submit. Success. Alright guys, the next thing that I'll be doing is updating the GitHub repository, and so basically there will be a folder day 3 over here, so that you can navigate all the source code for what we have done in the day 3 section. And I hope this was fun to watch, and let's break this video right over here. If needed, let me know in comments if you need one more video on LinkedLists, because I think LinkedLists is all about solving problems, and if you watch 1 or 2 videos, I think this one was pretty much detailed, and I also need to put my Mac on charge. But the main point is, I think this video gave you a fair enough idea about a lot of variety of things. I think it helped you in some way or the other, and if you think you need more videos on LinkedList, let me know. So day 4 will also be LinkedList then, and again guys, let me know in comments what you think about this one, and don't forget, damn, this is really making a lot of noise. And guys, don't forget algoexpert.io/Rachit to get your 30% off.